All right, so I'm going to talk a little bit today about we've been talking a bit about when you use the embedded cluster that you're sort of building a virtualized Kubernetes appliance. But there's more to the idea of a virtual appliance than just what goes on with Kubernetes. So we're going to talk a little bit about distributing a replicated application Kubernetes appliance as a full-on virtual appliance to your end customers. Um, what what sort of got me thinking about this? It was a little bit of my own thinking, a little bit of things that folks like you were talking about, where it was sort of an open question, right? When we install with the embedded cluster, it's pretty easy, right? If you, one liner to get started, install a Kubernetes cluster, install your application. You've ruled out a lot of the uncertainties that you might have at the level of Kubernetes, which are, quite frankly, not just, uncertainties that are technical and about Kubernetes and the cluster, but also that are about potentially, the team that's doing the work and everything. You kind of set them up to work in a very easy way where they don't have to think about Kubernetes really at all. You handle the upgrades of the cluster, you handle the installation of the cluster. They really can just think of it as, an underlying layer that you're looking after for them and we're looking after for you. But what if we could extend that certainty deeper into the stack than just the Kubernetes cluster? Um, well, you can, and you can do that by distributing the application as a full-on and packaged virtual appliance. What we mean by that is essentially a machine image that you can start up and it will take care of running the application and the cluster and everything. And again, so instead of not just having to think about Kubernetes, your customer's team doesn't have to think about the operating system, how the file systems are laid out, all of those types of questions. So let's take a look at this. I think that the best way to do this is to show you a little bit about what it looks like. And so I'm going to show you a little bit of a vSphere installation here, where so we're working in vCenter. This is for your customers that use VMware. Their administrators who might be installing your software are going to be pretty familiar with this environment. This is a place they're going to work in managing VMs and installing applications as appliances in going through even actually they can even manage Kubernetes here if they want to. So with this environment, you can sort of go through and you can select to deploy an OVF template, OVA, OVF. There's only minor differences really in between the two. We can upload our OVA appliance. So this is it's essentially just a tarball of the OVF. It's a template that specifies sort of what the VM is going to look like, it has an image of the disk. And on there, we have sort of laid down the bits we need to run an air-gapped embedded cluster install. So this is now parsing through there a little bit because it needs to reflect some information back to the person doing the install about the virtual machine that's about to be created. Tells us a little bit about how big it was to download, its configuration. Now they go through, they set up kind of where is its disk going to live. They're going to set up networking, and then they're going to be able to customize this. Now, this is something that we've added in here. These are properties for the installation of your application using the embedded cluster. We have these three at the top here that are pretty standard for using user data with installing onto vSphere. And then we have some, and over here, I'm just grabbing my SSH key so that I'll be able to get into this box if I need to, although ideally I won't ever need to, right? This is going to just come up at the end with the embedded cluster at the admin console running on port 30,000. We have two fields here that kind of distinguish whether this is going to be the first node or a joint node. If we enter the license file, it's required if it's going to be our first node because we're going to do an install and we're going to need that. And it's a little bit of a weirdness when you use these that it requires the base 64 encoded value because it kind of gets dropped into an XML. We're going to have the password for the admin console that you're used to entering on the command line. And then when we're doing a join, when you've joined other nodes into a cluster, you see that you need the admin console address and you need the join token. We've given the join token precedence here in this template to avoid, if someone happens to enter both, we want to make sure that we actually go ahead and join rather than starting a new cluster with another first node. So I can grab my license file here and encode it in base 64. Maybe not base 65, but base 64, and then pop it up onto my clipboard, and then pop it into this encoded license file field. And then I use my convention of throwaway passwords being old programming languages, Smalltalk being the one that I primarily use. So I entered that in. That's what we're going to enter as the password when we go over to the admin console after this spins up on port 30,000. This, depending on the vSphere environment, you can see that it's sort of, the machine has started to show up there, but there's kind of a, you look down at the bottom, there's kind of a task going on. This could take different amounts of time depending upon the vSphere environment. Quite frankly, in mine, it took a very long time because I run way too much stuff for the size of the two little machines I have hanging on the wall in my garage to run this. But eventually, that VM is going to, be fully instantiated, power it up. Depending on what they selected, they might have to power it up themselves, or have it come right up, and then they're going to be able to go right over to that you see it running and go over to the admin console on port 30,000 and go through the experience that you would expect to finish the install. Now, so far so good. Some things that we're used to doing, except we just didn't trigger this off the command line. After we log in here with that super secure password that you now all know is my default, when I don't care about security, we're going to get the screen where it asks us about adding nodes. Now, we're not going to add nodes here, but we are going to take note of that join token there because we're going to use that, excuse me. We're going to use that when we install another node onto this machine. So we pop back over. We go through this process again of uploading our OVA. There are ways that you can, vSphere administrators can put that into what they call a content library, and not necessarily have to do this. They can create a template. There's lots of things they can do to not have to take wait the extra time for the upload. But I'm just sort of doing it the lazy way. Again, stepping through these same processes, but this is our second node now, right? We created the first node. That's, the one that's going to be the, that we did an install, and it's going to be the first node of our cluster. Now we're creating a second node that we're going to join. We're going through the same process of selecting the storage, specifying its networking, excuse me, and then getting that custom template. We'll put these, these first few fields on here to be the same so that we, have information about the machine and where it's sitting and where, et cetera. And then instead of entering our license and our admin console password, we're going to enter in the address of our admin console. When I was doing this, sort of pre-recording this, I didn't remember the IP, but, which is great. They've got it open in another tab. They can always check over to double check that. Even if they hadn't grabbed the token yet, they can click over there and grab it and enter it in, and then hit finish. And again, we go through sort of that instantiation process, which is going to be dependent upon the characteristics of the vSphere environment that we're installing into. So once we hit finish here, it's going to start instantiating, and we're going to sort of wait for that to finish, and then we can eventually, we'll see the VM is there. We'll see it's up and running, and we can pop over to the admin console after that, and we'll see that our cluster now has, instead of just one node, our cluster has two nodes. So pick that admin console tab, and you can see I have news, and I have the one that I forgot to rename from the default Slacker news macro. And I can continue through with my install as I might, otherwise do to finish installing the application. And have my now two-node cluster available. I know it's not a great idea to have a two-node cluster if they're both controllers, which in this case they were, since I didn't specify one of them as a worker. But you get the idea. I probably should have gone through and installed the third. So, so that's a great experience for your customer, right? They don't have to think really much about what's going on. They can jump through, just spin that up. They didn't have to log into any of the boxes. They didn't have to run any special commands, right? Entirely pure ClickOps experience. So why would we want to do this? And the main reason is that the operating system is still going to create some variability, right? We've gotten rid of the availability in the cluster, the variability in the cluster, but we haven't gotten rid of the variability in the operating system, right? They could have things like headaches with permissions, the file system differences. We had a ton of issues early where people were like, oh, we can't write into that file system. We can't write into this file system. This one's really big. Now you can deploy to different locations and things like that. Like we've adapted to that, but still, you know, you don't want them to have a first run through where they run into problems and then have to kind of you know, make corrections. Same with types of things that might happen with permissions, right? I don't have permission to do this thing you need me to do. Oh, sudo. Oh, we're going to have to install it 2 days after I file a ticket and it gets back to me so that I can get sudo rights for the amount of time I need to do the install. Start to make all those things go away. In addition to you know, maybe other system problems, right? They could have just some variability in the system where you know, the 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 embedded cluster is sort of isolated from problems that could be caused by host packages. But there's other things that could go wrong. There could be, you know, certain types of enforcement going on that might, you know, inadvertently delete things or might, you know, not allow different writing in different places. They could have, you know, something turned on like SE Linux when you weren't expecting it and hadn't necessarily thought through everything that it needs. So a whole lot of things that could go on there at the operating system level that you don't have to think about anymore. So how do we solve for this? Well, we solve for this by, okay. We solve for this with this by creating this virtual appliance. It's a standardized environment, so every deployment is going to be identical, right? You're going to know the way the disk is laid out. You're going to know all the permissions that they have. That all the sudoing is not going to have to be done by a user, right? In the background, there's, you know, things are running as root because we're using Cloud Init, and the Cloud Init is running things as root. Um, you have even fewer dependencies on things for your customers to do, right? We have very few when we start with the embedded cluster, right? They don't have to go out and install any certain host packages for you, et cetera. But you have even fewer, and you reduce manual steps, right? No one has to get onto a box and sudo and have to, you know who has the sudo, et cetera. And then your rollouts are going to be faster, right? You saw that experience. This was ClickOps end to end, right? I was either ClickOpsing in vCenter, my VMware environment, or I was ClickOpsing in the admin console. So great solution to some of these problems that can come up. So how does it work? How do we build this? So there's some things that your team's going to do, obviously, to build this appliance. And there's some things that your customer's team is going to do in order to install this appliance. It is built around the air-gapped bundle. So these are de facto air-gapped machines. We take, in this case, I started with an Ubuntu ISO. No reason it has to be Ubuntu. It could be from the Red Hat lineage, or it could be another Debian variety. And then we use Packer to create the virtual appliance. We do that by downloading, you know, in that process, we download the air-gapped bundle. We unpack the air-gapped bundle. I happen to put it, since the default for embedded cluster is varlib embedded cluster, I put it in, I put it in varlib AppSlug, essentially. So for me, Slacker news macro. I create a user with that name, right, with the AppSlug name, so that when they do have to get into the box with those credentials that they entered, they can get into the box using that username. And then, you know, we churn through a process of generating that virtual appliance and making that OVA file available to our customers. Once the customer has that OVA file, they get a hold of their license file, and they can go through the process that you saw me executing there. The upload the OVA. They might have other procedures that have to happen before that, where maybe they have to scan it, maybe they have to put it into a vSphere content library. I wouldn't be worried about that. Like their team is going to know what to do with an OVA file when they get it. And so they're going to put your OVA through that process. And then they're going to go clicking through just like we saw. It would have the appliance, they'll import the appliance, they'll initiate the configuration of the appliance. Once it's configured, it's going to start running. Once it starts to run, we have a job that runs with systemd that does the install. It checks to see if the embedded cluster has already been installed by looking for a file. And if that file is not there, it's going to run based on, it's going to run a shell script. That shell script is going to look at those properties that we entered. If it has a join token in there, it's going to sort of take a branch where it runs a join command. And if it doesn't have a join command in there, it's going to take the license file, admin console password. It's going to run the embedded cluster install, and then it's going to have spun up, and you're going to have a little bit of time passes, obviously, and then the admin console is going to be listening there on port 30,000. I did this with the vSphere, mainly because it's a good, it's a solution, and when people aren't in the cloud, they're going to, you're going to often see them using. And I did it because it gives you that nice GUI for entering in that configuration. You can do this in various cloud environments. For example, I use this exact same image generation for distributing with the AWS Marketplace. I just use CloudFormation to handle grabbing the license and doing the setup. You could use some of the other mechanisms for starting up, where you could, also be able to enter that stuff, have user data running through the process. So you could do this with basically with any virtualization environment, and not just vSphere. But I wanted to show that one today. So let's take a look now at what it takes to build the appliance. So we'll hop over here, and we're starting. I have a repository out there on GitHub. This repository is actually how I build either an AMI or an OVA. And Martez from my team has started working on the Azure equivalent of an AMI. I actually don't remember what Microsoft calls it. But hey, he's an old school Microsoft guy, so he knows what to call it, and he knows how to build it. So he's going to add that into here as well. And eventually we'll add GCP and probably some others. But for today, again, we're focusing on the vSphere environment and what we do with the OVA. This generator is built around the makefile, having a little bit of sort of, it would be perhaps grandiose to call it metaprogramming, but it creates a bunch of make targets by accessing your replicated vendor portal account. You have a YAML file you configure with the information that you need to connect to your vCenter server, connect to the vendor portal, and if you want to build AMIs, to connect to AWS. And then you can see I've got, because of the way the makefile works, it's going to build a bunch of, it's going to essentially create its own set of targets. And then when I just wanted to show that by showing all the available targets, and you can see, if you look at all of these, they're like OVA : AppSlug : channel slug. So right from here, I can just run make with my AppSlug channel slug combination, and I can build the OVA for the release of that application on that channel. Calling out to Packer. Packer's doing the hard work here. It's even delegating some of its work over to Cloudinit. And then it's going to run for a while. And at the end, it's going to create first an OVF. And then I run a little Python script with that OVF to add in those additional properties that we want to use. Again, this is all happening from within that makefile. The cool thing about this makefile being driven off of the vendor portal account and sort of coming up with this dynamic list of targets is you can just go clone this repo, set up that params file with the stuff that you need, and then you can right away start making these images using Make. I even set it up for anybody. I use Nix, and so it sort of can bring in a bunch of its dependencies using Nix, so that you don't even have to worry about the tools being installed. But if you, listen, I list the dependencies and everything, so you can install stuff if you need to. Now, that's going to take a little bit to run through, and the end result is we're going to get that OVA file that we used, that our customer used in the previous example, to run through and do their install. Really do not want to be. There we go. So why am I going to do this, right? We have a nice, smooth customer deployment. We deliver a single file. It's its application, its cluster, it's the underlying virtual machine. It's all configured. It's one single download. Technically, there's a second download because they need to get the license file, but listen, all the bits that are important to run the thing are in a single file. It is fully ClickOps, right? This experience is ClickOps from the beginning to the end. Nobody jumping on a little command line and worrying about flags and having to run help and make mistakes. It's fully ClickOps. Um, and it's going to be smooth and error-free, right? There are pitfalls lurking in your customer's operating system configurations and controls, no doubt. Many of you have run into them. We've done a lot with increasing pre-flights to help out with that. I'm sure your pre-flights help out with any of those possibilities. But there's always going to be some new control, some new configuration that you haven't seen, that we haven't seen. And instead, if we just bring along the operating system, we don't have to worry about any of that. It's going to be smooth, it's going to be error-free. And coincidentally, these all end up being air-gapped installs to boot. So what's next? Please try this out, right? I've run it with my environments, my vendor portal team. I've built AMIs, I've built OVAs, done installs of those OVAs. I've used those AMIs in the marketplace. But you know what? The more things like this get looked at, the better they get. So please go out, give it a try. If you want to create these for your customers, that should give you something that you can honestly that you can ship right away. You may want to tweak a little of the hardening of the Ubuntu environment or something like that, but it's a pretty it's a pretty solid place to start from and even continue from. But I do want to qualify that this is not a supported replicated product. Right? My team builds something. It's a demonstration. It's as is. We want to make it as robust as we possibly can, but it's not a product. It's not something you can call support for. If you are interested in the possibility that something like this type of delivery could become part of our platform, please let us know. Talk to your account executive, talk to your SE, talk to a product manager. Just let us know. We'd be very curious to learn where this might fit into your plans, how we might, if we decide to go down the road of productizing this, what it might look like. So please, if you're interested in that, let us know. And otherwise, you can always find me on Slack in your Slack channel, just at Chuck, and I'll be happy to answer any questions.